Andrew, and I work with Neil Doran on Essentials for PepperDash. In today's video, we're going to look at how we use the feedback class to move data around Essentials and also out of Essentials into simple windows using bridging over EISC. We're going to cover bridging more in depth in the next video, so make sure you come back and check our channel for that next video. Anyway, let's jump in and take a look at the feedback class. In today's video, we'll discuss the feedback base class, the three existing implementations, the Boolean feedback, the int feedback, and the string feedback, creating and using a feedback, and consuming a feedback. First, let's look at the feedback base class. The feedback is based on a publisher-subscriber model, with the feedback as a publisher and a couple different ways to subscribe to the data changes that the feedback is handling. The first is an event on the feedback. This is called the output change event. It has feedback event args, and we're going to go look at those event args. So this is the event args class. We've got a property for each of the different values: bool value, int value, ushort value, or string value. Int and ushort are the same, but just have a different property type, integer versus ushort. And then we have an enum that has the type of the feedback, whether it's Boolean, analog, or string. This gets used so you can tell what changed and when. Back in the base class, all of the feedbacks inherit from or implement the iKeyed interface, which is kind of a standard interface in Essentials. That allows them to get added to the device manager if you need to, so you can retrieve it by key. We have a test mode Boolean here. We have properties for all the different value types that could be included in a feedback. Boolean, int, string, or serial. There's not much difference between the string and serial, but they're there. We have a test mode Boolean. When you put a feedback in test mode, you can use the dev.json method. This is for testing or debugging. So you can fire the feedback and make sure the changes happen downstream everywhere they need to. Got a couple constructors, take a key in. Otherwise, we just do it. We just build it. Clear your test value to reset everything and fire an update with the real value. This is an abstract method. We'll see where these get implemented later on when we look at the bool feedback, string feedback, or the int feedback. Also, this invoke fire update calls the same method, just calls it on a new thread, so that if you have a long running thing or lots of things subscribed to this feedback, you can use the invoke fire update to fire it off on a new thread so that you don't tie up your main thread. And this is where the output change gets sent. There's one for each type. Again, there's a bool, int, and a string. And so that creates the correct feedback event args and creates the correct event. Next, we're going to look at the bool feedback, int feedback, and string feedback to see how these things are implemented. Now that we've looked at the feedback base class, we're going to look at one of the first implementations. We're going to look at the bool feedback. Bool feedback is used for true-false values or digital signals if you're thinking simple window. So first we've got the bool value property, which overrides the property from the base class. And then we've got a private bool value that is used to set the value that is going to get returned. This is used when we update the value, or this is used from the base class or from the class that implements the feedback to say, this is the value that you're going to set. This is the fake value here. This test value property is the value that we're going to use when the test mode, remember we saw the test mode Boolean in the feedback base class. When that is turned on, this is the value that will be returned when the fire update method is called. Here we've got a func bool that is a value func that we'll look at when we get farther on when we talk about creating a base class or creating a feedback, see how this func is used to update the value. Then we come to our second method of consuming a feedback. This is you can link a SIG, which a SIG is the class that's used for touch panels or Ethernet Inter-System Communications, EISCs. And in the Boolean feedback, we have a couple lists of SIGs. We have the standard one, which has our linked input SIGs, and then we have linked complement input SIG. When you add a SIG to the linked input SIG method or list, it will always be set to the same value as the bool value field up here. So if it's true, the linked input SIG will be high or true. If it's false, the linked input SIG will be false or low. The complement SIG will be the opposite. So if bool value is high or true, linked complement input SIG will be false. The reason for this is this allows you to link something like on-off feedback where you want both values, but you don't want to have two feedbacks have to manage two different feedback classes, trigger two different updates at the same time. So this lets you automatically link those signals and link those feedbacks with one feedback. The constructor here takes a func, which again, we'll see when we talk about creating a feedback. Again, another constructor with key as well. This method is what is fired when you call the fire update method. This overrides the base class. This is what actually does the work of updating the thing. So we go through, and if you look, we check for the new value. If we're in test mode, we set it to the test value. Otherwise, we get the value from the function that we talked about earlier, the value func, and we'll see how it's used later. If it's a new value, if we don't want to fire the update unnecessarily. So if we have a new value, we're going to send it. If it's the same value, no reason to send it, so we're not going to. So we set the field in here to the new value, and then we go through, and for each input sig and complement sig, we update them. We call a method to update them, and that is farther on down here, and we'll look at that in just a second. We also fire the event, the output change event, with the Boolean value and the new value. This method here, link input sig, lets you add a sig to the list, to the linked input sig list, and then updates it with the correct value at the same time. We also have unlink input sig, which lets you remove a sig from the list. Same thing for complement, link, and unlink, and setting their current values. This links a feedback, which you can link a feedback to this if you need to propagate things throughout the program. This tells you this toString. So if you print this feedback, this is what you'll get. You'll see this. You'll see it'll say test and then dash dash. Or if you're in test mode, you'll see test and dash dash. Otherwise, you'll see the Boolean value. This lets you set the test value using the dev.json methods that we talked about. And here's where we update the sigs. We just set the sig bool value to the right bool value, and you can see we're setting it to the opposite here on the update complement one. That's the Boolean class. The int feedback and the string feedback are very similar, other than the complement sig, because ints and strings don't have complements. So we've got the int value property here for the integer feedback. We got the private value field. We got a ushort value as well, which just casts the int value to a ushort value, just in case you need a ushort, which would work with EISCs. Again, we got the test value as an integer. We got our value func, which again, we'll see when we implement one of these. The linked input sig list, which notice we don't have the complement sigs. We've only got the one list because we don't have complements for integers. They're just a single value. Constructor that takes the func and the key in the func. And then same fire update method. It's other than, again, the only difference is the linked complement input sigs. And all these methods are very similar to what we just saw in the bool feedback, because it's just the same thing, just for inputs or integers and ushorts. Take a quick look at the string feedback, but it's very similar to the integer feedback, other than strings instead of ints. Also, we don't have a cast to a ushort because we just have a string. Just take a quick scroll through here. Got our feedback with the function, the fire update method, which loops through and fires the output change event, and sets it to, if it's in a test mode, it gets the test value. Otherwise, we return the true value. Same thing here, link a sig, unlink an input sig, setting values, updating sigs, etc. So those are the three classes that we have implemented in Essentials. Up next, we're going to see how to actually implement one of these into a plugin. We're going to look at the same plugin that Neil showed in previous videos, which is the Mock Occupancy Center. And we're going to implement a raw feedback or raw occupancy feedback value. Now that we've seen how feedbacks are implemented in Essentials, we've got the bool feedback, the int feedback, and the string feedback. We're going to take a look at how to implement a feedback in your own plugin. We've got the mock occupancy detector device, which we saw Neil go through how to create your own plugin. So check out that video if you want to see how we got to this place. Now we're going to add a raw occupancy feedback to this. So first thing I'm going to do is I'm going to create the feedback property. So we're going to put it in that region. That's okay. We're going to go here. We're going to go public bool feedback. We're going to call it raw feedback. And we're going to do the same thing as down below. We're going to do a get and a private set. We do a public get because we want other classes to be able to get this feedback and subscribe to it and use it and do things with it. But we use a private set so that it only gets set internally, so that we don't, so another class can't change this and do something funky with it. Now we're going to do the property in the class that this is actually going to return and change on. So first we're going to do our private backing variable. And then we're going to do the public property. And for the get, we're going to return the raw occupancy backing field. And for set, we're going to make it public. And we're going to do some of the same things we see up above with is occupied. We're going to check if it's not occupied or if it's the same value. Debug the field just so we can see it. And let you know what we're actually saying. So we're going to say raw occupancy, do our replacement value, and we're going to say raw occupancy. And then we're going to fire the feedback. So we're going to say raw occupancy. And remember what we saw looking back in the feedback classes, this will go through and link any attached SIGs, any attached complement SIGs, and also fire the update so that anything that is subscribed to the update for this feedback will change. We'll get the new value. We do this in the set so we don't have to remember every time we set the raw occupancy public value, we don't have to remember to do all this and fire the update. So now that we've got those things, I'm going to go back and initialize it. And this is where the func that we talked about comes in. So first we're going to go and we're going to create the constructor. Now we get an error because it doesn't have a func. So we're going to return that property, the raw occupancy property. So what'll happen, this creates a little anonymous method that returns a Boolean and doesn't do anything else. It doesn't take any properties in. It just returns a value. So it's going to return the raw occupancy value every time we call the fire update method. The feedback class will go check this value, and that's what it'll use to set the linked input sig to, and this is what it'll use in the fire update when it fires the occupancy change, or I'm sorry, fires the on output change event. And that's really all there is to it when we are implementing a feedback. So next, we're going to take a look at how to consume a feedback from another device. Now that we've seen how to implement our own feedback, we're going to take a look at how to consume a feedback from another class or another device. The scenario here is we've got multiple occupancy sensors and we want to aggregate their value into one, which is what we're going to do in this mock occupancy detector. So that means that I need to go get a device from the device manager in Essentials. We're going to get it by key. Right now we're going to hard code that key. It could come from config. It could come from any number of places. And then we're going to get the feedback out of that device and we're going to subscribe to it. And we're going to do something with when that event changes. So first off, let's get the device. I'm going to use a local variable here. And we're going to get the device by key. And so our key here, we're just going to say some occupancy sensor. In the real world, this would be something that is in your config that defines this device. And we're going to cast that to the same interface we're using here, the occupancy status provider. So we're going to check it for null, because if that device is not an occupancy status provider, we don't want to get a null reference exception. And then we're going to subscribe to the device's feedback. So we're going to go device, room is occupied feedback, .on, .output change. And we're subscribed to it here. We're just going to use a local lambda here. And for now, we're just going to write this to console. We're going to say debug. And remember, we're going to just do it at 0 so we always see it. We're going to go to this. And since we know it's a bool feedback, we're going to just go directly to the bool value. If you aren't quite sure what kind of feedback type it is, you can use the arguments feedback type to determine that. And that's really all there is to it to subscribe to use another device's feedback. All right, so let's recap. In this video, we looked at the base feedback class in Essentials, the 3 implementations that are in Essentials already, which are the Boolean feedback, the end feedback, and the string feedback. We also looked at how to create your own feedback and use it in your own plugin, and also how to consume a feedback from another plugin or device. Now we're going to cover how to use feedbacks to bridge data to simple windows over EISC more in depth in the next video, so make sure you come back and check that one out. If you want to get notified automatically when the video gets posted, make sure you like and subscribe to our channel. Thanks for watching and have a great day.